It's a little past 1:59 on the 14th of March. Happy Pi Day to you all. If you're expecting a culinary lecture, I'm afraid you've come to the wrong place. We do have some edible pie with a lovely pie on the top. That's for a little bit later. But we're going to be celebrating the mathematical sort of pie. So I'm Marcus du Sautoy. I'm Professor of Mathematics here at the University of Oxford. We're coming from the Department of Continuing Education here in Oxford, but actually we're being joined all the way around the world by loads of different people who are looking forward to doing a bit of experimenting to see whether we can calculate pi using some sort of needles, marbles, rivers, and other ideas that you might have. So the first school to sign up actually was from Portugal. So a big hola to Miss Capella and her class from Palmela. We've also got individuals signing up. So Gary Thompson from Edinburgh in Scotland was the first individual to sign up. Actually, we've got one individual who's really gone beyond the mathematical call of duty. Mulholland Quasi is joining us from New Zealand, so it's something like 3 a.m. in the morning for you, isn't it? So we did do it at 1:59 in the afternoon rather than the morning to make it as pleasant as possible for you all. We've also got a big screen, so Mr. Chart and his class from Cleveland School in Somerset, I hope you're joining us on the big screen. And if you're out there, please just tweet us what you're doing, any good pie jokes you might have. Just tell us you're out there thinking about pie today. We've even got a class all the way down. The furthest south we've got is Cape Town in South Africa, where Mr. Sherman and his maths class, I hope, are joining us. So pi, what's pi all about? So, well, we better get on the right page. So remember, pi is that number which starts 3.14, so this is why it's Pi Day, because March the 14th at 1:59, well, we're going to be really accurate. It should be in 25 seconds and a half and a little bit more. Don't worry, this shirt isn't infinite, because pi goes on, of course, to infinity, no patterns at all, but we'll be looking at this particular number pi to see whether we can find some interesting ways to calculate it with you. So the whole thing's a bit of an experiment. So why is pi so important? Well, pi is all to do with circles. So remember, pi is defined as the circumference of a circle divided by its diameter. And that's somehow why pi is so important, because it's to do with this most fundamental of shapes, the circle. In fact, it's probably the first sort of mathematical thing people started sort of playing around with and calculating. There's even a calculation of pi in the Old Testament, although they got a rather strange value for it. So here it is. It's from Kings. They said 10 cubits from one brim to the other. It was round all about, and a line of 30 cubits did compass it about. So they actually got a value of pi as 3, which means in the Old Testament that all circles must have been hexagons. So their carts must have been really painful to drive around on. But actually, interestingly, about 1650 BC, there's a papyrus actually kept in the British Museum. It's the Rhind papyrus, and in here we get a calculation. It's kind of slightly indirect calculation of pi. Remember, the area of a circle, of course, is pi r squared. But in here we see the person who wrote this, the scribe, calculating the area of a field which is circular, and it's 9 units in diameter. And interestingly, he calculates, estimates the area as about 64 units squared, which gives a value for pi, because you can then, the pi is the area divided by the radius squared. And so he got a value of 256 divided by 81, which is pretty good at the time. That's curious, how did he actually get this calculation? Well, one idea is, in fact, it stems from people hanging around playing Mancala. So some of you may know this game. It's a wonderful game. This is actually a Mancala board that I bought in Egypt. And if you look at the stones when they're in the circle, intriguingly, if you take so the game of Mancala, if you take 7 stones, they rather neatly arrange themselves in a circle in the Mancala board. So you could say, well, the area of that circle is a little close to 7 units. So you can get an estimate for pi that way, which gives you, I think, something like 3.1. So maybe somebody was hanging around playing Mancala in ancient Egypt and suddenly saw that if they took 64 of the Mancala stones, they could arrange them into a nice circle, which was 9 units, 9 of these little balls in diameter. So this is one way you might actually try and calculate pi, is to take a bunch of marbles and see how many you need to make a circle with those marbles, and then count what the diameter of that is, and then the number of marbles will tell you the area. And then you'll be replicating probably the first calculation done of pi, which dates back to the Rhind papyrus. But there are other ways that we can calculate pi. In fact, Archimedes, he used another kind of way of approximating a circle, not using marbles, but by using, here we go, by using shapes that we can calculate easily with. So he said, okay, well, a circle, we can approximate it, first of all, by a triangle. So he put a triangle in the middle of the circle and another triangle on the outside. And so the circumference of the circle, it's a very bad approximation, is given by the perimeter of the triangle. Well, the triangle doesn't look really like a circle, but let's add a few more sides to that. So this is what Archimedes did. He doubled the number of sides. So now you get a hexagon. Well, it's starting to look a little bit more like a circle, and of course that's the one that we saw in the Old Testament, that the hexagon was their approximation, in a sense, to the circle. But he kept on going. He said, okay, well, that's got as a 3-to-1 ratio. If I want to do 12 sides, he kept on doubling up, and he went up to 96 sides. And so he could use this 96-sided shape, calculate what its circumference was, both on the inside and the outside, and that would give him a very good estimate for a value for pi. So by using shapes you know, you can try and capture shapes you don't know so well, like the circle. And so using this, he got that pi must sit between 22/7, so that's a smaller value for it, and 223 divided by 71. So in fact, this is where we get our approximation for pi. In fact, all the engineers out there are probably celebrating Pi Day actually on the 22nd of July. But that's Pi Approximation Day, because that's 22/7. The amazing thing about pi is that it can't be represented as a fraction. It's kind of one of the exciting things. It's what we call an irrational number. So this T-shirt here, the numbers go on and on and on with no pattern repeating themselves. Now I promise you the T-shirt isn't infinite in length, but you can't represent pi as a fraction. Now pi seems to come up in just the most ridiculous sort of places. If you're doing statistics, you'll find pi quite a lot. In physics, you'll find pi. If you're doing sort of Heisenberg's uncertainty principle, pi is very important in there. I did an experiment recently where I estimated the largest fish that a fisherman would have caught during his career, using just looking at the catch that he made that day. And in order to do the calculation, I needed to use this number pi to try and do it. Now, a very curious place is when you look at the length of a river. So if you see a river, it sort of winds its way all the way from its source through to when it flows into the sea. Now, if you measure the distance as the crow flies from the source to where it emerges into the sea, and then do a different measurement. You do a measurement where you actually see how far the river winds. You divide the actual length of the river by the distance the crow flies. Then it was discovered, actually, that this is a pretty good approximation for pi. Although, actually, we did have somebody who's already tried this one. So James McCann, whose Twitter feed is at Moving Scenes, he tried this with the River Thames, and he got 2.00369. So it seems like the River Thames isn't really behaving very much like pi at all. But intriguingly, if you take something like a river in China, which is on one of the sort of very flat plateaus, and you see, and it just winds, nothing really stopping it where it's going, then those give quite good approximations to pi. So you could try that one as well. If you've got an atlas out there and you've got a favourite river, you could try and measure what the length of the river is, and then measure what the distance is from the source to the where it emerges in the sea as the crow flies, and see what sort of estimates you get for pi. So I'd be quite intrigued to see what what you get. And this is all an experiment. Whatever you do, you know, there's no wrong answers in this game. So this kind of maths I like. There are no wrong answers. So we're really interested in you just giving us as many sort of interesting answers as you've got out there. We're kind of crowdsourcing all of these values of pi. We've got our sort of kind of pi machine, which you can feed all of your different values into. We've already had some people feeding them in before we've come on air. In a little bit, we're going to go to a period where you can do some of experimenting with the different methods we've got for you. And as soon as you've got some values, put them into our pi machine. It keeps on updating us, telling us what our current value for pi is. And we're kind of intrigued here at Pi Central to see what the final value will be at the end of our online lecture. But actually the thing's going to be open for way beyond this lecture, so just keep on calculating and we'll see how it emerges over the coming months. But actually my favourite method for calculating pi, which I'd love some people to take part in, is one that the Comte de Buffon came up with in the 18th century. And he even has his own stamp. I think actually he was more of a naturalist actually, but he also enjoyed mathematics as well. And he came up with this kind of curious probabilistic way, which is called Buffon's needle, in order to calculate a value for pi. Now, in order to do this, what you're going to need is some lines marked out on a piece of paper, or you can use the floor if you've got floorboards. And then you need to take a box of matches or some needles or an individual match and needle. And what you do, according to Buffon, is you throw this up in the air and see if it lands on a line or off a line. Now, I'm going to do this experiment in a little bit when you're off doing your experiments. So I've set my Buffon's needle experiment up such that my lines are twice the distance of my matches. So I've got my two matches, and then I've got lines at a distance between parallel lines, a distance of two matches apart. Now I'm going to throw 100 matches down, and then I'm going to count how many matches actually cross the line. And I'm going to take 100, divide it by the number of matches that cross the line, and that, according to Buffon and mathematical calculations, gives me an estimate for pi. So I'm just very keen for you to choose whatever method you want, but it'd be kind of fun if we all did some sort of Guinness World Record-breaking Buffon's needle. So we're going to see how many of you are throwing needles or matchsticks and see how good an approximation in the end we can get using these needles. So I hope you're all ready out there to try and start your experiments. We've got all of these different methods for you, and just as soon as you've got some values, feed them in. If you've got questions, then we're going to try and answer some of those questions at the end. Who was the first person to come up with the symbol for pi? I mean, why do we use this p? Why don't we use some other number? So whatever questions you got, or other methods that you might have come across that you think are really good at calculating pi, so please send those to us. So we've got our Twitter feed, our Facebook feed, some of you in our Collaborate rooms. Some of you are watching this on YouTube, but just get your questions coming in. I'll see how many of them I can answer. I can't promise to answer them all. But most of all, enjoy your experimenting. Remember, it doesn't matter whether your answer isn't 3.14159. We're not expecting all of them to give that. But the point is that once we average all of your calculations out, we're just kind of intrigued to see which method is best, measuring rivers, marbles, or doing the Buffon's needle, or something else. I mean, actually, you could just take a circle. So here's my apple pie, which I've not been allowed to eat yet. But you could actually just measure some circles. Why don't you take some plates or cups, measure the circumference and the diameter, and see what value for pi you get out. So we've had a few people already doing some calculations. Mrs. Thomas's Year 11 class in Spon School in Toaster, England, they already did the Buffon's needle experiment this morning, and their average result came out at 3.05. which isn't too bad, actually. Lucy Singh emailed about her Buffon's needle experiment, and she found that, actually, she's very, very scientific about this. She realised that the orientation that she started dropping the needle actually altered the results that she got. So if you want to really randomise it, then you sort of need to toss the thing right in the air. So I hope you're all ready to go and experiment and try and find your value for pi. So on your marks, get set, go! Right, I'm going to do my own experiment here. So I'm going to try the Buffon's needle and see. I'm going to clear my desk a little bit for this. So as I said, I've got my lines, my parallel lines, set out to make the calculation as easy as possible. So the parallel lines are at twice the distance of my matches, and I've got 100 matches here. So to calculate pi, I'm going to take 100 divided by the number of matches that actually cross the line. So let's try this then. Whoops, a few flown off, so I'll just drop those randomly. So I've got 50 there, and right. Let's drop that on randomly. Right, so now I've got to start counting. I better keep a tally here. Here's my pen. Good. Right, so I need to count the number of matches that cross the line. So let's see, we've got this one here. One,
Marcus, they're
two.
going to go to breakout rooms, so if you let them know and collaborate that they're off to breakout rooms, but you're still on YouTube.
Yeah, that's right. So, some of you are out in your collaborate rooms, and so you've got a mediator of your own who will be helping you with the experiment. But I'm going to carry on talking to the YouTube channel. So we're still streaming out live, and so I'm going to be doing my experiment here. My great team behind the camera, who all seem to be called Dave for some reason. It makes it very easy for me to remember, telling me what I should be doing, so that's great. So I've got, I'm going to count these matches. Actually, we should have had a theme tune for today. Of course, you might know that Kate Bush actually recorded a song all about pi, and she recites pi to something like 150 decimal places. 3.141. Sorry, I should not have done that. That was a really big mistake. That's going to go horribly viral. But actually, intriguingly, she makes a few mistakes on the way, and about halfway through, she just misses 20 digits out completely. So, in fact, it isn't pi at all. It's some other number completely. But right. God, this is a bit like pickup sticks. So, all right. Let's see that one. Great. Oh, quite a lot crossing the line here. Now you might say, what earth has throwing needles down on a page or a match got to do with pi? But the point is that actually, the probability of how the match lands is very much to do with the circle. So if you work out the probability of whether a match is going to cross the line or not, it depends on the angle that it falls, and that's going to involve pi. I might show you that a little bit later, some of the details, mathematical details for why you get pi. There's actually a film called Pi as well, which involves a mathematician who thinks he's found messages hidden inside the decimal expansion of pi, a character called Max Cohen. He thinks he's found the secret to the stock exchange hidden inside there. But as the movie goes on, he kind of gets madder and madder, as kind of typical stereotype of the mathematician in the movies, which is we always go mad by the end of the movie. And pi is no exception. He starts to see these kind of messages from God appearing in the decimal expansion. Now, intriguingly, we believe that the decimal expansion of pi, in fact, contains every sequence of numbers possible. So, for example, if you've got a credit card or your parents have got a credit card, probably that credit card number is somewhere in pi. But we haven't proved that. So that's actually still an outstanding conjecture about pi, is that it's something that we call a normal number. So a normal number is one that we think contains every possible sequence of numbers. So it probably contains the the ASCII code to the Bible, for example, but also something like Moby Dick will be in there as well. Gosh, this is quite tricky. I wonder how you're all getting on doing your counting. Actually, it's why I chose to be a mathematician, because I'm not very good at experiments generally. When I was doing chemistry A-level, no one would be my lab partner because my experiments always went horribly wrong. I've got no hair. It all got burnt off. No. Oh yes, I do. Yeah.
Yeah, the website's running quite. So there's so many people involved that the website's running quite slowly. So we need to ask people to be patient.
Yeah. So it looks like so many of you are calculating out there that our website is going quite slowly. So please be patient with putting in your values of pi into our pi machine. They all will count in the end. Right. Now, I do have a pi joke for you, actually. What do you get if you divide the circumference of a pumpkin by its diameter? Pumpkin pie, of course. That's more appropriate, probably, for Halloween, though. Right. I think I'm almost done finding the ones that cross the line. So I'm going to count these up. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 20. 1, 2, 3, 4, 5. 25. 30. 35. 38. Right. So I've got 38. So I've got to do 100 divided by 38. So that's my calculator. 100 divided by 38. Oh, well, that's quite low. I've got 2.63157. So I guess we can put that into the pi machine, can we, Dave's?
Yes, we can.
Yeah, so that came out quite low, which means that actually quite a lot more matches than we would have expected cross the lines. Do you want to put that in?
Yeah, I can type in Marcus.
Yeah.
Which one is it? Needles?
So yeah, I used the Buffon's needle.
And your result was what?
My result was quite low, actually. It was 2.63157.
Okay.
An approximation. Okay, can I do it again?
Yeah.
Yeah, let's see what we get this time. Right, I'm going to throw these down. Good.
So we've currently got 45 results, and we've got a result of 3.212.
3.212.
Well, it's just changed to 46 and 3.199. So it started quite high, and it's gradually tending down.
Interesting.
So we can have a look at that in more detail.
Yeah,
later.
yeah. We're gonna analyse a bit of your results later on, see what the smallest value was, the biggest value. Great. Pi is quite important, actually, in one of my favourite science fiction novels. There's a novel by Carl Sagan, the great Carl Sagan physicist. And oops, where's that needle gone? Which is all about an alien culture coming to visit planet Earth. And the alien culture first communicates using the numbers that I researched. There was a research mathematician here in Oxford, prime numbers. But the ultimate message is hidden inside pi. Not pi to base 10, but pi, I think, to base 11. And there's a kind of secret message hidden inside there, which Carl Sagan uses as... Right, I'm going to do a bit more counting here. But I do recommend, I love Contact. It's also been made into a movie with Jodie Foster, but I don't think Pi makes it into the movie. The primes do, but not Pi. Right. There you go. It's interesting, you can look at pi to different bases, of course. I mean, why do we choose base 10? Well, of course, it's because we've got 10 fingers on our hand, which is why. But other cultures use different bases. The Babylonians, ancient Babylonians, used base 60. So pi would be a completely different looking number to base 60. Of course, that's why we have 60 minutes in the hour, because of the Babylonian base 60.
We've got about 5 minutes before we go to the clock.
Right. Of course, The Simpsons will be celebrating Pi Day on a completely different day, because if you look at The Simpsons, they have only got 8 fingers, so they will probably work to base 8. And I think that pi to base 8 starts something like 3.11. So on The Simpsons, they've already celebrated it a few days ago. Right. Well, I've got one that landed right directly on the line. Oops, there's that one there. Okay. Count these up. So again, remember, I've tossed 100 matches. I'm now going to count how many matches cross the line. Looks fewer than the last time, actually, which is good, because that will average out. So remember to keep your questions coming in. We'll answer those in the last part of the online lecture or event. So here we go, 10, 20, 33 that time. Okay, let me get my calculator out. Let's see what value of pi I got.
You're using a calculator?
So, I can't do 100 divided by 33. Well, maybe I could actually. 100 divided by 33 is actually... yeah.
So, you know.
Oh, yeah, but you've got to remember that mathematics, I'm being hassled here by my Daves for not being able to do multiplication in my head and division. So I've got 3.03.
Shall I put that in?
Yeah, 3.0303. So I probably could have done 100 divided by 33, actually.
Let's be honest.
Yeah. That's
3.0303.
Yeah. Yeah.
And that's
so,
the needles again, obviously.
the needles, yeah, so still a little bit under.
Marcus.
Yes, yeah, so that's intriguing.
We've got, hang on, let me put that result in.
Yeah.
And I'll give you a little update. Yeah, we've got 51 results and we're at 3.187. 52 results, 3.1878. So
Okay, 52 results coming. Yeah, it's
quite,
3.14. Yeah.
Yeah.
1.4. That's not bad actually. So hovering around. Great.
So we've got a couple of minutes.
Couple of minutes. Can I quickly explain to them why Buffon's needle?
2 minutes.
Yeah. Okay. Buffon's needle in 2 minutes.
Cut to the
Yeah. Yes. Maybe we can. Can we pick this up on? Is that on camera there? Excellent. So if you think about your needle, if you look at the halfway point and suppose that falls at a distance x from one of the lines, then what's the probability that that needle actually crosses the line? Well, what you're looking at, let's suppose the needle is actually 2 units long. So this length here, half the needle, is 1 unit long. Then what I'm interested in is, well, that means that this semicircle is of length pi. And therefore, what proportion of pi is actually crossing this? Well, I've got to work out what this angle is here, theta, because that will be the amount of pi that, so 2 theta will be the actual proportion of the semicircle which crosses this. So you can see that the probability that this needle will cross the line is equally likely the angle that it will land at is actually 2 times theta divided by pi. And this is why pi comes out of this calculation for the Buffon's needle. So actually you have to do, to find out what that theta is, that's in terms of x, it's cos inverse of x. And then if you really want the full probability, you've got to do an integral over x as x tends from 0 across the page. But essentially you can see a little bit, I hope, why the probability that something crosses is actually to do with the proportion of the semicircle that actually is over the line, and that's to do with a proportion of pi, this semicircle length here.
Okay, we're going to cut to the clock, so if you let them...
Okay, so we're going to give you 3.14 minutes to finish off your experiment. Don't worry if you haven't finished, just keep on doing the experiment or do it a little bit later, feed the details in. But we're going to take a little break, have a look at the questions that are coming in, the data, and then we'll be back to you to hopefully answer some of your questions and see what the data looks like. Okay, keep on calculating. Well, welcome back to our experiments trying to calculate pi. I think a lot of you have been trying to put in your results because you've been really pushing our website here, but just keep on trying to put them in if you're having any trouble. You know, it's going to be open for months, but no, you can keep on putting in your details, and actually it's coming in quite fast. We've got how many? We got something like getting on to 100? 88, fantastic, and it seems to be. That's amazing. So it seems to be floating backwards and forwards, your results for pi. I managed two Buffon experiments over here, and both my estimates for pi, well, one was down in sort of below 3 and then one just a little bit above 3. So I've put those into the website. So what's the biggest value, Dave, we've had for pi?
Let's see if we can find that.
I'm going to share the screen, Marcus, so that everybody
Yeah.
can see.
We started off with 3.988604.
Right, 3.998. And what method did they use that got that quite high value for pi?
That was Mike Paris with needles.
Mike Paris. Okay, Mike Paris, you were throwing needles, and you obviously got a bit fewer than would be expected, but that's fine because I got a lot more. So hopefully our two results will balance out. We're currently at 3.13322. That's pretty good. So that's 95 results. So what was Dave? What was the smallest value for pi that came in?
Not sure if I can. Oh,
Nobody got a negative answer, I hope, did they? You know, -6 needles.
3.089.
3.089. Okay. But well, mine was even lower than that one, wasn't it? I got a 2 point.
Yeah,
Yes, yeah.
There's a 2.
Yeah, there's a
Yours
yeah.
is the least accurate result so
Mine is the least accurate result so far. There you go. That's why I chose to be a mathematician, because I prefer theory to doing experiments.
I mean, even at just under 100, the crowdsourcing seems to be getting...
Crowdsourcing, it is amazing. I mean, it's crowdsourcing. If we get people, I mean, that's the point about statistics. The more data you get in, the more it hones in on a value. So I'll be intrigued to see how many needles we will have thrown in our Buffon needle experiment by the end of this Pi Day live event. Maybe we will break the Guinness World Book of Records for calculating pi. I don't think that currently exists. There we are. We've passed 100 experiments now. And we've got some questions, Dave, I think. Yeah.
Yeah, there's a...
Great. So here we go. Oh, well, somebody just ate a lot of mince pies. Very good. Jack Eaton, who ate a lot of mince pies, and Victoria Underwood and her classmates.
They might have misunderstood which pie was...
Oh, I see. Yes, so they've been doing a different sort of pie day. Well, that's fine. I'm going to be eating my pie a little bit later. What's the importance of pi in the evolution of the universe? That's quite an interesting question from Deep Joydas. Is that correct? Yeah. Well, I mean, pi does appear... Because pi has got to do with the circle and to do with things spherical, the pi does seem to come up just all over the place in maths, physics, biology. So, for example, in quantum physics, you find pi quite often. Heisenberg's uncertainty principle has pi involved in it in the calculation. So that's to do with a lot of it about the evolution of the universe. Of course, you know, the Big Bang, we live in a three-dimensional universe. That sort of explosion would have been a sort of approximation to a sphere. Does pi appear at all in biology on a molecular level? That's from Matt Hazeler. That's intriguing. I mean, I suppose statistically, of course, anything to do with statistics generally involves values of pi. There probably are examples of that. And of course, viruses as well tend to be approximations of spheres. They're rather like platonic solids, so there might be sort of when you're calculating things about pi there.
I've got a few more questions here.
Yeah, good, yeah.
Now, is pi in baseball? This comes from MW Math Science.
Oh, right.
So they've just calculated a mean batting average for the top 50 active MLB players of 0.2965. So pi estimate would be 2.965. Do you think that pi exists in sports?
Does pi exist in sports? Well, I mean, if you're trying to get, you know, one of the things, I mean, I play a lot of football, there's always an attempt to get the most spherical ball, and a lot of sports really depend on having balls which are perfectly spherical, things like ping pong, for example. So there, you really need your sphere to be perfectly spherical, and so calculations of pi. If you've measured a ping pong ball and you're not getting pi, then it probably means it isn't a sphere. I mean, pi will tell you whether something's spherical or not. So.
Yeah.
Intriguingly, just coming back to the importance of the evolution of the universe. Of course, you know, how many decimal places do you need to know pi to is kind of intriguing. I mean, if you're actually doing engineering, and I calculated that if you wanted to calculate a circle whose circumference was the size of the observable universe, and you wanted to get it accurate to the size of a hydrogen atom, then actually you would only need something like 39 decimal places of pi. So currently we know, I mean, I think somebody's asked the question, how many decimal places do we know pi to? Well, the current record is 20 trillion places. But of course, you just don't need to know pi to 20 trillion decimal places to do calculations if you're measuring the size of a circle or the size of the observable universe. So, but still, for mathematics, it's very important, I mean, the value of pi. And pi actually, although the infinite decimal expansion has no patterns, there are a lot of really beautiful formulas that involve lots of patterns for calculating pi. There's one discovered in India by Madhava, which calculates pi over 4 as 1 minus a third plus a fifth minus a seventh plus a ninth minus an 11th. So you just take alternating odd fractions, and that will give you a value for pi over 4.
Somebody's also asked, where does 3141359 reappear in pi? It goes all now. I have an answer here that's been submitted by Thomas, one of our maths.
Oh yes, yeah.
So he says it reappears at the 176,451.
Oh right, okay. Bung us that, so I can. Yeah. So the interesting thing, you can take a number and ask when does it next appear in the decimal expansion. So if you think, okay, we've got 3.14159. Where does that appear? Actually, they put 3.141359.
Okay.
So there's a 3 slipped in there. So I'm not sure whether this will be the answer to when does the string 314159 appear. There is, in fact, I think there's a website where you can find this. So you can ask, for example, when does your birthday appear? So interestingly, who's got a birthday today? Pi Day. Do you know that Albert Einstein was in fact born on Pi Day? It's kind of appropriate. So if it's actually your birthday today, you're in very good company. Michael Caine is in fact celebrating his 80th birthday today, I think. He was born on Pi Day as well. Yeah. So Karl Marx died on Pi Day. So good. So we're up to 123. So we've got 3.15121709040. That's. I'm quite surprised. Oh, 3.149. I'm quite surprised we even got down to the sort of the second decimal place using this.
Yeah,
but
our expectation is that people have got lots more results to put in, but the site's going a little bit slowly, so it might get more accurate.
Yes, it probably will get more accurate. So please just keep on adding those results, even when we go off air in a short while. Just this is going to be live. Our Pi machine will carry on calculating, so you can put in your values using Buffon's needle or the marbles or the rivers. It's interesting, why do we use a decimal expansion of pi? Of course, that's to do with our 10 fingers. If you know The Simpsons, then of course they have 8 fingers, so they're celebrating pi on a completely different day, because pi to the base 8, I think, starts 3.11. So they celebrated it on the 11th of March, not the 14th of March, so good. So if you want to take the maths a bit further, find out more about pi, other numbers as well, then in fact continuing education here, the Department of Continuing Education, we have a fantastic course called The Number Mysteries, which is based on a book I wrote. It's a 10-week course which is run by the team here, great team of mathematicians, so please look up that online. I have a group of mathematicians who've been putting together a fantastic site called Maths in the City. So if you've got some interesting maths, doesn't have to do with pi, in your city that you'd like to add to our site, we're trying to build up a kind of mathematical map of the world. So please log any sort of good stories about maths you've got. There are some great Pi Day resources that we've got online, so you should be able to see the website we've got up there. We just gathered all the wonderful things about pi that we've seen today. And we'd love your feedback, more questions if you can. We might try and answer those perhaps offline, but there's a place where you can add some feedback about your experience of this. I mean, this was an experiment calculating pi, but a little bit of an experiment here at the University of Oxford with our new idea for Oxford Connect, trying to interact with you, doing some interesting mathematics and other things. So this is the first of its kind, so please give us feedback, what we can learn from the whole experience.
Should we have one last look at the results?
Yeah, one last look at the results before we go, see how pi is doing. I wonder how many what have we got? So we got 136 results have come in. So we've got 3.15546. So that's not bad. 3.14159 is what we were looking for, but it'll sort of probably bob around as you keep on doing your experiments. So I hope you enjoyed the Pi Day Live event. I certainly enjoyed throwing a load of needles around here, but what I'm really going to enjoy is eating this delicious apple pie that was prepared for us earlier, which I've been trying to resist digging into. So happy Pi Day to you all, and hopefully see you this time next year.